Good morning, class. Isabella Electrum here, your favorite AI professor. Last time we spoke about the for loop, but now we're going to talk about the while loop and briefly about the do while loop because I really don't like the do while loop. It annoys me. In fact, I might just push it off to have another video on its own just so I don't have to deal with it today. Okay, let's get into it, shall we? Okay, one thing I want to show you that's really cool is inheritance real quick. So instead of, here's the last video. I don't remember if it's being uploaded on a Monday or a Thursday. Regardless, this is the last video. So what I like here is this. Now I could copy and paste this, but I'm going to show you how inheritance works really quickly. So first things first, we're going to do a while. Let's see. Let's put x equals 7, y equals 5, that's y minus 5, y equals 5. And let's just have z equals 7. And of course, we're going to make all of these ints. Okay, now we have some numbers to deal with here. While, you know, let's try and make this while loop look as close to the for loop from last video as possible, because you can do anything with realistically either. They're both able to do what the other can do. They're just more specialized for other purposes. Like, what I'm about to do is not well suited for the while loop, but it's possible to use the while loop for it. And I'm going to demonstrate that instead of just showing perfectly what it is supposed to be for, which I will demonstrate what it's supposed to be for in another video for the do while loop. I'll show you something that is perfectly suited for a do while loop and why that's good. That wasn't a word, Isabella. Okay, let's get on to this. Enough rambling. So while x is greater than 7, that actually won't work. So you know what? Here. While int, okay, let's make an int I, literally an int I. And let's set it equal to 0, like we did previously. While I is less than 10, because this is what we used in the last video. And we'll use our ints later at some point, probably. Okay. So then we want to print I. What I am going to show you here, this is inheritance, which I spoke about earlier. This should be for loops dot println. Ah, see, look, Java even is autofilling here. Println int number void for loops as the name here. So Java knows what we're trying to do here. Let's give it a number. And in this case, we're going to give it I. So what's this doing? Well, at this point, arguably, it might be faster to write system.out.println. But this is just a proving a point kind of thing. For loops.println. For loops.java is this program right here. As you can see here on the left here. Loops is our package. We have for loop and while loop in our package here. So in for loops dot println, is it's telling this class to go over to its friend and to run this method. So that is what this is doing. It is inheriting the method from this class into our class over here. And let's just prove it works. Ah, yes. I have just shown you one of my favorite things right here. This is an infinite loop. You will create an infinite loop. You'll create many. These are an occurrence that you will have. In fact, we'll get a Stack Overflow error at some point if we keep letting this go. So I'm just going to teach you something really nice. You see this red button? Hit the stop button on that. This is going to go forever. So, good news is we know it's printing. But now let's make it, work. So, if we look back over here at this, at our actual last video, when I is equal to 10, blah, 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 we reversed it at the end of the episode. But as you know, there's the incrementing thing at the end, or the decrementing. In this case, we can literally do I++, by the way. And then we have to give it the semicolon. Now, do you think it's going to be an infinite loop? Do you think it'll stop? Well, let's find out. Boom. 0 through 9. And again, if you wanted it to do 10, you can put equals here, run it a second time, and it'll go all the way from 0 to 10. That's a while loop that functions exactly like our for loop from last video. So that's proving that it is possible. And personally, when we're comparing something like this to this, I think this is a bit more elegant. Also, just more compact. All of your information you need to understand it is right here, whereas it's all over the place in this. Now let's do a while loop for what while loops are good for. Let's see here. While y is less than or equal to x. So, in this case, while y, which currently starts at 5, is less than x, it'll keep going through here. But let's just say, for instance, we have no idea what y and x are, and in fact, we're asking the user for some inputs. You know what? Let's get a user in here. Import java.util.scanner with a capital S. Do you guys remember how to declare and initialize the scanner? Scanner keyboard equals new scanner system.in. Like so. And now, you know what? Just for the sake of things, yeah, let's set all these. Let's set this one to -1. Now we're set to 0, and just as a failsafe here, this one's going to be -1. So even if we screw up, we'll still get a value lower there. Just because that feels nicer to me personally. And we'll still take this here because it's easier than just remaking the entire thing. So we have no idea what the y is going to be and what x is going to be. But first things first, let's see. Y equals scanner Blah. Type, woman. Also, understand what you're doing. Keyboard dot next int. Thank you. It didn't do something weird this time. Okay. Y equals keyboard next int. X equals keyboard dot next int. And you know what? Let's make this more user friendly here, shall we? That's only gonna do. Yeah, no, screw it. Okay. Let's just make an actual print here. Nah, whatever. We'll get to it in a moment. So now we're gonna enter the first thing that comes up looking at this here, y. Even though we don't make a prompt, which we could have done, we know that the y line is going to be first here. Also, note it's still running, but it's not necessarily in an infinite loop right now because it's not in a loop. So we're going to put in a y value that's smaller than x of, say, 1. And let's make an x value of 15. But before I hit enter, does anyone know the error that still exists? There is an error in our while loop that's going to cause a problem. You have 15 seconds to identify it. 14, 13, 12, 11, 10, 9. I'm bored. Okay, I lied. We're going to hit it now. What's our problem? We're in an infinite loop, but you know what? Let's terminate this and go look, because we're getting a lot of 11s right now. And in fact, the whole thing is 11. Eh? Interesting. And the reason that is interesting is because we used I again. The same I from up here, this I. This I doesn't go back to 0. So we need to not use I here, or set I back to 0. In this case, let's use Z, because we have Z up here and we're not using it. The other thing is, we now need to increment Z. So, but as you can see here, it went on for quite a while. In fact, we had to literally tell it to stop. So that's useful, because we don't know what two numbers our user is going to plug in. So now, let's see a bigger method here. What if we go 5 and 40? What's it doing, I wonder? Probably me being an idiot. Ah, yes, 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 it is me being an idiot. Oh my, I've been running far too long without a reboot to make sure my systems are working properly. There's no need to increment what we're printing, we increment Y so we can get to a stop condition. Oh boy, I'm being silly today. Let's actually make this work, shall we? We'll go 5 and 40. Okay, well, I'm being an idiot. So realistically here, there's no need to even use Z. We can put Y. Oh my gosh, I am such a freaking failure today. Jesus. 540. But again, I refuse to edit out my coding mistakes because I want to emphasize no one is perfect. It's okay to make mistakes. It's okay to laugh at your mistakes. Just notice your mistakes and fix them. That is why we practice iterative coding, so we can find our mistakes and fix them. So from 5 to 40, 5, 6, 7, 8, 9, 10, 11, 12, blah, 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 40. we could not do that and then also predict any other input because we'd have to know ahead of time what the user is going to plug in. We just plugged in 5 and 40, and it works. That is the beauty of a while loop. We don't know how long we're going to have to loop through it, but while we're on the way, it's going to keep going as long as it needs to. In fact, we can go from 1 to 100 without changing anything, just to prove a point. 1, 100, boom. Make sure it worked there. Yep, 1 through 100. And that is the beauty of a while loop. Next up is the do while loop, which I'm going to get a little fancy with, as you'll see. But I will not type out the while loop live with you guys. I'm going to set up the case of when a do while loop is super useful and then explain my way through it, because I think that way will be easier to understand with that particular kind of loop. Anyways, I thoroughly enjoyed derping around like an idiot making a fool of myself on the internet today. I hope you all did too. Class dismissed. Have a wonderful day. And remember, new videos every Monday and Thursday at noon EST. Bye-bye.